Hello, in this video, we are going to be going over the final for semester 1, fall, and just going over the main concepts here. So in our first question, we have points A, B, and C are collinear. Remember that word collinear means on the same line. So I'm going to go ahead and draw out a line. And we know A, B, and C exist somewhere on that line. We know B is in between them. Okay, so I'm going to put A on one of the ends, and I'm going to put C on one of the ends. And we know B is somewhere in between that. We don't know exactly where. Your diagram doesn't necessarily have to be drawn to scale, but I'm going to put B here. And then we know that BC is 21. Oh, actually, I'm going to move B a little bit over on this side. So we know BC is 21. So I'm going to put 21 for the length of BC. We know AB is 17. And we are looking for the length of AC, that's this right here. So remember, with segment addition, we would just be adding these two parts together. So we're going to add 17 with 21. And I encourage you, as you're working on this test, open up that Desmos Scientific Calculator. You could just Google that at the app. And we're going to be adding 17 and 21 together. So our segment length is going to be 38 for this one. All right, on our second question, this one is also segment addition. However, the diagram is already drawn and set up for us. So we've got the entire line segment, 31, and we have the part from C to D is 16. So we are looking for this other missing piece here, okay? So we need to know what number when I add it to 16. So I'm gonna say what number, we'll use X plus 16 is equal to 31. So what number we'll add with that? So the way we can figure that out is undoing the addition. We could subtract 16 on both sides. So we're going to say X, or X in this case is the length of BC, our question mark there. We're going to take 31 and we are going to subtract 16, and that should be 15. So our missing length there is 15. Okay, one more segment addition question, but this time we have expressions for each part. So we have our first part, QR, that is 6x minus 8. And then we have our part here, which is 4. So plus 4. And then what we need to equal it to is the length of the whole line. The length of the whole line here is 5x, so equals 5x. And then we're just solving for our variable. Before we start adding or subtracting anything from both sides, we're going to go ahead and combine our like terms, -8 and 4. So 6x, when I combine -8 with 4, that's minus 4. And then I would subtract a 6x on both sides. And we want to subtract that so we bring all of the x's to one side. So we're going to bring all the x's over to that right side. So we're going to get -4 equals a -1x or negative x. But we need to know what a positive x equals, so we can divide by -1 on both sides. So -4 divided by -1 is 4. 4 is our value for x. Okay, now we're looking at our different angle types. So we want to have an angle that's obtuse here, and we want it to be called angle I. So remember, obtuse is greater than 90 degrees, but less than 180. So we are looking for, this one here is acute. So that's not the right type of angle. This is also an acute angle, less than 90. This is a right angle. So this would be our obtuse angle here. And it is labeled with the letter I and the vertex. So this would be question D. And then we are looking for a straight angle. So straight line. Well, that's this one here. This is a right angle. Let's just review the types of angles. This next one, this is obtuse. This is an acute angle. That means our first one, this one here, this is a straight angle. It's a straight line. CBA, B in the middle, which is the vertex. So this is our straight angle. Okay, now we're moving into some angle addition here. So we have SKL. So I'm going to trace from S to K to L. And I'm going to place the number 48 there. And then we can trace from J to K to S. So that's J to K to S. That's this part here. That's 44 degrees. So what we are looking for is JKL. Let me use a highlighter for that. So we're looking for JKL. So what we're looking for is actually the entire angle. So we can take 48 and we can add 44 with it to get the entire angle for that. Okay. And when we add that, that should be 92 degrees. Yes. So that's our angle addition postulate. Okay, and in our second problem, we're going to go ahead and label these angles as well. So we're first going to label EFU. So here's EFU, and then that's going to be, oh, that's the measure of the angle we're finding, rather. We have EFG. EFG. That is the entire angle. So when I have the entire angle, I actually like to just put kind of like a little arrow around it. So we know this entire angle is 154 degrees. And we know that angle UFG, here's UFG, this is 104. So what we are looking for is this missing piece here. So we need to know what number, when I add 104 to it, is going to give me 154. So we can actually subtract them to figure that out. So 154 minus 104, that's going to be 50 degrees. So 50, when I add it with that angle here, is going to give me the total angle. Okay, on question 8, we're still going to be doing some angle addition. So let's start with EDC. That's this entire angle, EDC. Trace from E to D to C. So that's going to be 11x plus 9. And then we've got EDY. That's going to be 5x minus 9. And we've got YDC. YDC, that's this angle here, is 72. So we need to use angle addition to set up our equation for this. So we can take 5x minus 9, add 72 to that, and equal it to 11x plus 9. And before we start adding and subtracting different things to both sides, I would combine like terms. So let's combine our 72 with our negative 9. So when we combine that, that should be 63. Then we can start adding and subtracting to both sides. I like to bring all my variables to one side, so we'll subtract the 5x. So it would give us 63 equals 6x plus 9. Subtract 9 on both sides. That's going to be 54 equaling 6x. Divide by 6. And that's going to be 9 is our value of x. But we're not solving for x, we're solving for EDY. And EDY is 5x minus 9. So we're going to need to do 5 multiplied with x minus a 9. So that's going to be 45 minus 9, which is 36 degrees. Okay, here we have some of our area formulas. So we have area of a triangle. Remember, area of a triangle is base times height, all divided by 2. Okay, so in this triangle, our base, this is our base, It's 89. This is our height, 68.7. So our area for this figure is base, 89, times height, 68.7, all divided by 2. So we're going to need to put that into our calculator. So 89, and we're going to multiply that with 68.7. This is how you should be inputting it into your calculator, and then it's all divided by 2. So we're going to end up with 3,057.15. Okay, here we had a triangle to start, now we have a parallelogram. And remember, a parallelogram is really just a slanted rectangle. Okay, so for a parallelogram, your area is the same as whatever it would be for a rectangle. So it's just base times height. So here's our base, and here is our height. And so if we multiply those, we've got 8.1. We're going to multiply that with 12.1. That's going to be 98.01. And one more area formula. This is our trapezoid. Remember, a trapezoid is the height multiplied by the sum of the bases, all divided by 2. So in our diagram here, this could be our base 1 and base 2. Those can be switched around, it doesn't matter. And then here's our height. So for our area is going to equal the height, 17, our base, 9 plus 20, all divided by 2. So we've got 17, 9 plus 20, all divided by 2. Let's see how that looks in the calculator. Great. And that's going to give us 246.5. Here we're writing a rule for each of these transformations. So our first one here is a translation. So you notice here all of our options are translations. So we're shifting it. So this is the quadrilateral that we're starting with. So I'll highlight that. This is the starting quadrilateral in black. And I know the blue quadrilateral above that, that one is the new quadrilateral. And I know it's the new quadrilateral because it has the little prime markings in it. You notice here the little prime marks. Okay, so what I want to know is how many units am I shifting? So it looks like it's going up and it looks like it's going to the left. So up 1, 2, 3, 4, and to the left 1. So up 4, left 1. So remember our rules for our translations. When you add x plus a number, that's going to move the graph to the right. X minus a number, that's going to move our graph to the left. Y plus a number is going to move our graph up. And y minus a number is going to move the graph down. So let's match that up with what we have here. So we went up 4. So we went up 4 and we went to the left 1. So then you can just also add in the numbers for each of these. So we went left 1 and up 4. So if we look at our arrow diagram here, it'd be x minus 1 and y plus 4. And then on our next one here, we have a reflection. We have a reflection on this line here. This is what we call our y-axis. Okay, so we're reflecting it from this left side of the y-axis to the I'm sorry, the right side of the y-axis to the left side of the y-axis. And then we have here, this would be a reflection on the x-axis. Okay, so we have a translation here. We are subtracting 1 from x and we're subtracting 4 from y. So this is the coordinate that we're doing that to. So we're going to take the 5 and we're going to subtract 1. And we're going to take our y value, which is 2, and we're going to subtract 4 to that. And then we're just going to write out our new coordinate. So 5 minus 1, that's going to be 4, and 2 minus 4 is going to be -2. So 4, -2 would be the new coordinate. Anytime we have a reflection on the x-axis, remember if we look in our toolkit, I will move this over here really quickly. So we have some of those specific rules for reflecting on. So reflecting on the x-axis, the x coordinate stays the same and the y coordinate becomes negative. So x comma negative y. So we can write that rule down here. So if we look at our coordinate here, 3, -4, the 3 is going to stay the same and the -4 is going to multiply with a negative. So it's really going to change signs here. So that means we're going to end up with 3, +4 for our new coordinate. The only thing that changes is our y value. 3, 4, here we go, D. Our reflection on the y-axis. Let's remind ourselves what our rule is for that. We change our x coordinate becomes negative. So if you notice here, 0 stayed the same, but 3 became negative and 1 became negative. So our x coordinate changes, our y stays the same. So our rule so our x is changing sign, so this will change from a negative to a positive, and our 5 will stay the same. So we're going to end up with a 2, +5. And then we have 2 rotations. Rotating 180 degrees doesn't really matter if we go clockwise or counterclockwise. So our rotation of 180 degrees is basically changing the sign of both x and y. So if I take 5, 5, I'm going to change the sign for both of them, and I'll become -5, -5. And our rule for our 90 degrees counterclockwise rotation, that would be this first one here, -y, x, -y, x. So essentially what that's doing is it's switching the x and y, their places, and also changing the sign of y. So if I think about 4, 2, I'm going to change their location. So it's going to become 2, 4. And the y is also going to change signs. So that's going to become a -2, 4. All right, we've got some slope. So remember, slope is the change in y, vertical change over change in x. Okay, and remember 4 types of slopes: positive slopes, negative slopes, undefined slopes, and we've got 0 slopes. That's my slope man there. That reminds you of the 4 different types of slopes that we can have. So just right off the bat, this question here, I know this is a negative slope. And this one here, it's going up to the right. I know this is positive slope. And we don't have any examples of undefined and 0 for this. But undefined would be vertical, 0 would be a horizontal line. So what we want to do is create a little slope triangle. So our slope triangle, our vertical change here is 3. That's our change in y. And our horizontal change is 1, 2, 3, 4, 5, 6. And I know that this is a negative slope. So negative 3 over 6, when simplified, is negative 1/2. Okay, question 21. We've got our positive slope going up 2 and to the right 1, 2, 3, 4, 5. So this is 2 and 5. So vertical change is 2, horizontal change is 5. And then we've got our slope formula. So remember, our slope formula is y sub 2 minus y sub 1. That is our change in y's. We've got x sub 2 minus x sub 1. That is our change in our x's. And that's our formula for slope. So first step is just to label these as your first coordinate and as your second coordinate, x1, y1, x2, y2. And then we just need to go ahead and subtract them and simplify if necessary. We've got 5 for the y2 minus y1, which is negative 5. And then my x2, negative 15, minus x1, which is negative 6. Okay, so now we go ahead and add. And if you're unsure about your slope, I would definitely go ahead and use your Desmos calculator. We've got 5 minus negative 5, which is really 5 plus 5. That's going to be 10. And then we've got negative 15. This is really plus 6. Negative 15 plus 6 is going to be negative 9. And when simplified, we just have the one negative, so it'd be negative 10 over 9. Finding the slope of a parallel line and then perpendicular. So parallel lines have the same slope. And if you remember, we're writing this equation, y equals mx plus b. So our equation, this m is where the slope is located. So I know the slope for this equation here is 2. So if I want to know what the slope is for a parallel line, well, I know it needs to be the same slope. So it's also going to be 2. Okay, perpendicular lines. So that would be lines like this, creating a right angle. Okay. So when you have lines that are perpendicular, the slopes are opposite reciprocals. Opposite means positive, negative, plus or minus, changing the sign of something. And then reciprocals. So if it's a fraction, we're changing we're changing the a and b of the fraction, or whatever the numerator and whatever the denominator is. Okay, so if we're looking at this question here, our slope is negative 7 over 2. So m equals negative 7 over 2. Now, if I want a line that is perpendicular to that, I need to change it to positive. That's the opposite part of it, and I need to flip it, the reciprocal part of it. So my new slope is going to become positive 2 over 7. Okay, we've got all our angle relationships here. We have 5 different types of angle relationships. Corresponding. So corresponding are angles that are in the same relative position. So I'm going to draw a set of parallel lines. And I'm going to put an example of each of these actually up here. So first angle relationship, corresponding. Those are angles in the same relative position. So an example of that would be like this angle here and this angle here. Those angles are corresponding to each other. Same relative position. They're both on the left side of the transversal and they're both on the bottom of those parallel lines. Okay. Our next one, alternate interior. Okay, they would both be on the inside of these lines, but on different sides of the transversal. So that's an example of alternate interior. And then we've got same side interior. So we've got those parallel lines here. Instead of being on different sides of the transversal, they're going to be on the same side. They're not equal though, so I'm not going to put equal markings on them. And then remember our vertical angles. So vertical angles we create when we have two lines that intersect each other, and it's those angles directly opposite to each other. And then our last relationship over here is the adjacent. So adjacent are just angles that are next to each other. So like one example could be this angle here. I'll put my mark on it. And this angle here is right next to it. Adjacent angles. Okay, so now I'm going to have you try answering these questions. So you're going to answer question 25. The relationship between X and Y. What is that relationship? Okay, now you're going to answer question 26. The relationship between X and Y. Okay, you're going to answer question 27. Now you're going to answer question 28. And last angle relationship question, 29. Okay, now we're going to use some of our angle relationships to solve for missing angles in a diagram. So these are on different sides of the transversal. They are alternate interior. Remember, alternate interior angles are congruent when we have parallel lines, and we know these lines are parallel. So that missing angle is going to be 89 degrees. Question 31. These angles here are same side interior angles. Same side interior angles add to 180 when you have parallel lines. So we've got 129 here, and then we're looking for our missing one. So we're going to do 180, and we're going to subtract 129, and that would be 51. Okay, our angle relationship here, these are vertical angles. Vertical angles are opposite to each other when we have two lines that intersect. And so we know vertical angles are congruent, they're equal. So we're going to set up an equation for that. So we would say 8x minus 1 is equal to 6x plus 13. So we're just solving for x here. I would bring all of my x's to one side by subtracting 6x on both sides. So that's 2x minus 1 equals 13. You could then add 1 to both sides. 2x equals 14. Divide by 2 on both sides, and x is 7. Question 33, these angles are same side interior. Remember, we wrote up here that they add to 180, same side interior angles. So we're going to need to add these two things together and equal it to 180. So that means 8x plus 2 minus 6 plus 15x. and then we can equal it to 180. So we'll combine our like terms. We're going to combine 15 with 8. Those are all of our x terms. So 15 plus 8 would be 23. And then we're going to combine 2 and negative 6. That would be negative 4 equal to 180. We can then add 4 to both sides. That's going to be 23x equals 184. We can then divide by 23 on both sides. And x would equal that 184 divided by 23, and that will equal 8. And then our last angle relationship here, these are called adjacent angles. They're next to each other. And in addition to that, they're also adjacent angles, and they form a linear pair. So these angles also add to 180. So we should be able to say 50 plus x plus 139 equals 180. I would combine like terms for this. So if you combine 139 with 50, that's going to be 189. And if we subtract 189 on both sides, we'll get x equals negative 9. And it is okay to have an x value that's negative, as long as when you plug it back into the angle and you get a positive. Okay, now we have the triangle sum theorem. Remember, the degrees of a triangle add to 180. Triangle sum theorem equals 180. So we would need to take 180, and we're going to subtract 56, and we're going to subtract the 45 to see how many degrees we have left. So we've got 180 minus 56 minus the 45. And that would be 79 degrees. We're going to use the triangle sum theorem for this problem as well. So I know this angle here is a right angle. That's a 90 degrees. And I'm going to solve for this angle here first. So I'm going to do 180 minus 90 minus 57. So let's figure that out. So 180 minus 90 minus 57 is 33. So I should be able to put into my triangle here a 33-degree angle. Now I also know that these two angles here add to 180. So if I take 180 and I subtract 33, I will get the angle that I'm looking for there. And that should be 147 degrees. And we've got one more triangle sum. We need to add all of these together and equal it to 180. So I'm going to start with x plus 56. We're going to add that with the 50, with the 85, and we're going to set that all equal to 180. So I would combine all your like terms. So we've got 56 plus 50 plus 85. So that's going to be x plus 191 equals 180. We could subtract 191 on both sides. And that will be negative 11. And here we still are working with the triangle sum theorem, but we have what's called an isosceles triangle. Remember, isosceles triangles have two angles and two sides that are the same. So these two sides here are marked equal. And what that means is these two angles here are also going to be equal. So I'm going to put a 52 there. And so now we're solving for this missing angle here, x. So we should be able to take in a triangle 180 degrees minus 52 minus the other 52 degrees to give us that last missing angle here. So that's 180 minus 104, so that should be 76 degrees. Okay, now we've got our Pythagorean theorem questions. That's, remember, a squared plus b squared is equal to c squared. So remember, the C is your hypotenuse. It's always the longest side. C is directly across from the right angle. So I'm going to call this side here C. And then the other two sides we can just label with A and B's. So now we're going to do A squared. Instead of A squared, we're going to replace it with X squared. B squared, we're going to replace it with 30. And C squared, we're going to replace with the 34. So now you just actually have to multiply these out. So 30 times 30, 30 squared, that is 900. 34 times 34, or 34 squared, that is 1,156. Now we're getting x squared by itself. So that means we're going to need to subtract that 900 on both sides. And when we do that, we're going to get x squared is equal to 256. Now, the only way to undo something that's being squared is to square root it. So square root of x squared is x, and square root of 256, that is going to be 16. 16 times 16 is 256. So just a reminder where we find that on the calculator here is, let me erase all this, we got the square root button, that's right here, and that's 256, which is the 16. And that seems to be in good proportion with the other side lengths. And then here, pointing our right angle, this side is our longest side, it's our hypotenuse, the C side, and then we've got our A and B sides. So in the Pythagorean theorem, we can do A squared, so 15 squared plus B squared is equal to C squared. So we've got 15 squared, that's 225. And we've got 20 times 20, that's 400. Now in this problem, we're going to have to combine our 225 and 400. That's going to be 625 is equal to x squared. And then we're going to have to take the square root of this. So we need to know what number multiplies by itself to make 625. And that should be 25. Okay, we've got two proportion questions here. Our first one's pretty simple. So anytime you see a proportion, you're going to circle your cross products and multiply them to set up your equation. So 2 times r, that is 2r. And then you're going to multiply 4 with 9, 4 times 9. So this is 2r equals 36. Divide by 2 on both sides, and 36 divided by 2 is 18. And in our next question here, we have our cross product. So I'm going to set that up. I'm going to write this a little bit up here. We've got 4 multiplied with n plus 13. We are going to set that equal to our other cross product. That's going to be 7 multiplied with n minus 6. Then we're just going to distribute to go ahead and solve for that. So it's going to be 4n plus, and we've got 4 times 13. It's going to be 52. And then our other side, we're going to distribute 7 to n, 7 to negative 6. That's going to be 7n minus 42. Then we can subtract 4n on both sides. 52 is now equal to 3n minus 42. We're going to need to add 42 to both sides. And that's going to be 94 equals 3n. Last step, divide by 3. So 94 divided by 3, that should be 31.33 repeating. Okay. For our dilations, anytime you have a dilation and it's around the origin, you are basically just taking your scale factor, k, and multiplying it with your coordinate. So we have 3, we're going to multiply that with 0.25. That's going to give us our x coordinate, and we're going to do 1 multiplied with 0.25. And that's going to give us our y-coordinate. So obviously the 1 times 0.25 is just 0.25. And then 3 times 0.25, that's 0.75. Imagine 3/4. So this is our x-coordinate and then our y-coordinate. So 0.75 and 0.25. We have triangle similarity. So we want to highlight the sides that match up with each other the same. So SR here, which is x plus 2, 10x plus 2, that's this SR here, our S, that's going to match up with AB. It's in the same order. So I'm going to put those over each other in a ratio. So 10x plus 2 is going to go over the side that it matches up with, that it corresponds to 36. And then let's look at the other side. So RQ, that's 56. RQ, first letter, middle letter, CB, first letter, middle letter. And we're going to set up our ratio in the same order. So equals 56 over 48. Okay, so then we just have to multiply our cross products and solve for our variable. So we have one cross product here and our other cross product here. Now I typically will tend to multiply one term into the two terms first, just because I like the variable on the left side. And then we've got 36 multiplied with 56 in either order, 36, 56. Now we can distribute. So we got 48 times 10, that is 480x. And 48 times 2, that should be 96. And then we've got 36 times 56. And we'll subtract a 96 on both sides. And then our last step, divide by 480. And x is equal to 4. Okay, now we have our triangle similarity here. So we need to make sure all the sides divided by each other equal the same value. So I've got my small side, 28, with my small side, 77. So these are rotated around a little bit. Don't let that fool you. So those are my two smallest sides. Then my two middle sides would be the 31 and 88. And then my longest sides, 40 is the biggest and 110 is the biggest. Now you're going to want, all right, so using your Desmos scientific calculator, we've got the smallest side divided by the smallest side. Those were the pink sides, 33, 31, and 88. And then keeping this open in your Desmos scientific calculator so you can look at all the numbers at the same time and compare them. We've got 28 and 77. And then we've also got 40 and 110. Now, if all these numbers are the same, then the triangles would be similar because of their sides, side, side, side. Now, these two are the same, but my first one is a little bit different. It's a little off from that. So these triangles are not similar. Not enough information to prove that. So I would say not similar here. Now, if all the numbers simplify and they equal the same thing, then they will be similar. Okay, we'll look at our second example here. So remember, anytime you see a bow tie question, we know that these angles here are vertical and they are congruent to each other. Okay, so bow tie, we're going to look for vertical angles. And then we have our two side ratios. So we need to check those to make sure that they are the same. So smallest side in both triangles, this would be the 18 and the 24. And the biggest side in both triangles, that would be 52 and 39. So let's see if those ratios work out to the same number. So we'll do 24 with 18. And let's do 52 with 39. they equal the same thing. So this is a side angle side. Now it can't be side, side, side. And that's because I only have 2 side measurements, but I do have the angle in the middle of those triangles. So it is a side angle side similarity. And it looks like we're also creating the statement for that. So side angle side similarity. And we did a triangle ABC. So here's A, I marked it equal. And then this angle here, B, matches up with this angle here, L. They're in the same like relative position. And so this would be A, L, because it went to B, and then it would be C, would match up with M. So it'd be A, L, M, be this one here. They are similar because of their sides. And that is our similarity statement. Okay, here we have 2 angles. These are both 74, so we know that they're equal. That's good. And then we've got our side lengths. The smallest sides would be 10 and 31. And the largest sides would be the 14 and the 39. Okay, these numbers are not the same, so these triangles are not similar. All they have is one angle that's the same, so not similar. Okay, then we've got some angle measurements here. On 48, we have angle C congruent to angle U, and then this is a bow tie question. We've got our vertical angles in the middle also equal to each other. Okay, and then we've got, therefore, the last 2 angles would be the same as well. But if we have 2 angles that are the same, we know these triangles are similar because of their angles. So this would have to be angle-angle similarity. We don't even know any side measurements. So in order to do one of these 2, we would have had to know some actual side lengths and do some dividing to make sure that they were the same. So that would be angle-angle similarity. And then here we can use some triangle sum theorem to figure out our missing angles. So remember, a triangle is 180 degrees. If I subtract 79 and 38, we're going to get 63 for this missing angle. And then if I take 180 and subtract 77 and 40, we're going to get 63 for this angle here. So we've got 2 angles that are 63, that's the same, but 77 and 79 are not the same, and our 40 and 38 are not the same. So these are not similar. You need 2 angles that are the same to prove the triangles are similar. And then our last one here. So we've got our bow tie angles, vertical, that are congruent. And then we have these parallel lines. Remember, anytime we have parallel lines, we were looking at those angle relationships. Anytime you have parallel lines, if you trace out the parallel lines and connect them, we now have alternate interior angles that are congruent to each other. So these angles here end up being equal to each other. So we now have 2 angles that are the same. So we can get rid of 2 of our options here. We know these triangles are similar because they have 2 angles that are the same. We just need to make sure our statement is in the right order. So if I start with letter P, in the other triangle, I should start with letter P. And then I went to Q, so that should go to C next. And then I went to R, so that should go to D next. So they are similar because of angle, angle, and it would be P, C, D.